So for today we are going to continue our discussion all about rational expressions. And last time we have solved um, rational expression in lowest term, and at the same time we already discussed multiplication of rational expressions. But now we are going to discuss division of rational expression. At the same time, addition and subtraction of rational expression, and at the same time, complex fraction. So let's start first with the division of rational expression. So if you haven't watched my video about it, you can search it on the Intervention for Calculus playlist. And if you haven't subscribed to my channel, please do so subscribe. Okay, so let's start with this division of rational expression. So for the division of rational expression is we are going to tackle this step by step. So when dividing rational expression, we should always take note that we should get the reciprocal of to which we are dividing the function or the expression. So in this case, you have, if I'm going to rewrite this, 3x all over 2 divided by 6x squared all over 4. So this part of your denominator should be always converted into its reciprocal, and then we're going to proceed with multiplication instead of division, but by getting the reciprocal. So you have 4 all over 6x squared. And from there, you can reduce. So you have 3 all over 6, this would be 2, and you have x all over x squared would be still x. And of course, you have 4 all over 2, so that would be 2. So you have 3 times 2, that will be 6. All over 2 times x would be 2x. Okay? And of course, no, we can also see that we can cancel 2 or 6 all over 2 in here. Okay? Okay, so as we can see here, we have 2 all over 2 here. So, no need for 6. Why did I write 6 here? Okay. So, we can see that we can also cancel the 2 and 2 here. Because 4 divided by 2 is 2. And then 3 all over 6 is 1 half. So, you have 2 all over 2 here. So, this will become 1 all over x. Okay. Clarify that. Okay, you already have, again, 3x all over 2. We canceled it. 3x all over 6. We canceled it. We have 2 here. 4 all over 2. We have 2 here. And these 2's will cancel. So, that's why you are left with 1 all over x. Okay, for the second number, we have 10xy squared all over 3z. Now, we're going to multiply it by the reciprocal of this. So, you have 6z cubed all over 5xy. So, as you can see, let us try first to divide. So, you have 10 all over 5. That would be 2. You have 6 all over 3. Okay, this will be 2. Okay, you also have x cancelled. You have 1y cancelled. Okay, you have 1z cancelled here. So, if you can see that, you are left with 2 times 2. That would be 4. And you have y. 4y here. And then you have z squared because we actually minus 1 here because of this. All over 1. Or simply 4x or 4y z squared. So, this will be our answer for this. Okay? So, for number 3, need to have example here. We have x plus 2xy all over, you have 3x squared divided by, you have 2y plus 1 all over 6x. So, again, we need to get the reciprocal of the 2y plus 1 all over 6x and proceed to multiplication. So, you have 6x all over 2y plus 1 here. Okay? That's why we are going to simplify this. Okay? So, by simplification, we have 6 all over 3. We have 2 here. And you have cancelled x here. Cancel 1x here. Okay? So, and of course, okay, we can factor it first. So, you have 2 times x plus 2xy all over, you have x times 2y plus 1. So, I can still factor out x here. So, you have 2 times x, you have 1 plus 2y, okay, all over you have x here, and then you have 2y plus 1. And 1 plus 2y and 2y plus 1 is still the same by commutative property. So if I write this 2y plus 1 or 1 plus 2y, it's still the same with the 2y plus 1. As you can see, the x will cancel also. So now you are left with 2. Okay, so the answer here is simply 2 when we divide these rational expressions. Okay, for number 4, we have 9 minus x squared all over x raised to 4 plus 6x cubed. Okay, and that is divided by x cubed minus 2x squared minus 3x all over x squared plus 7x plus 6. Alright, the first thing we're going to do here is to, again, we have 9 minus x squared all over x raised to 4 plus 6x cubed. Get the reciprocal and then proceed to multiplication. So you now have x squared plus 7x plus 6 all over x cubed minus 2x squared minus 3x. So factor. First, we have 9 minus x squared, that's difference formula. 9 plus x, then 9 minus x. On the denominator, you have common of x cubed. So I can factor out the GCF, which is x cubed. So you have x cubed, and then I have x plus 6 in here. Okay? Multiplied by, I'm going to factor out this. So that is x 2 times 3. No? So what two numbers, when we multiply, it will be 6, but when we add, it will be 7. Okay? So we're going to have 1 and 6. So you have x plus 1 and x plus 6. Positive 1 and positive 6. Multiply positive 1 with positive 6, that is 6. Add positive 1 and 6, so that will be 7. So that will be the factored form. All over. So as you can see, in the denominator of this, all have common x. Okay, I can factor out x. That's the GCF. So you have x squared minus 2x minus 3. Okay. And this x squared minus 2x minus 3, can we factor this out? Let's try. I think we can factor it. Okay. We can factor this out. So you have 9 plus x, then 9 minus x, all over x cubed, and then you have x plus 6, multiplied by x plus 1, and then x plus 6, and then you have x. Factor it out. What two numbers, when multiplied, it will show to negative 3? I think that is negative 3 and 1. And when you add, it will be negative 2. So it's negative 3 and negative 1. So you have x minus 3, and then you have x plus 1. Okay? So that's it. Oh, I'm sorry. Okay? This should be 3 plus x, not 9 plus x. Okay? So 3 plus x, 3 minus x. Okay? So because 9 minus x squared, I have x here, and I have, if I get the square root of it, this would be 3. So x, 3 plus x and 3 minus x. It should be 3, not 9. Okay, I'm sorry. So this would be 3 plus x, 3 minus x. Alright. So if I do this, class, okay, what will happen? Okay. So if I take the negative, again, we can see here, we have several cancellations. First, we have x plus 6 and x plus 6. That's canceled out. Okay? So, but we have x minus 3 here, and we have x plus 1 here. And I have 3 minus x here. So if I factor out the negative in 3 minus x, this becomes x minus 3. And then you have 3 plus x all over x cubed. X plus 6 is already canceled. You have x plus 1 here. And you have x times x minus 3 and then x plus 1. Okay? Of course, the x plus 1 also will cancel. The x minus 3 will cancel. Okay? So now you are left with, again, you have negative 3 plus x all over, you have x cubed multiplied by 1 all over x. Okay? So if I do that, that would be negative 3 plus x, okay, and then x raised to 4. Okay? So that will be our answer. We can rewrite it as negative of 3 plus x all over x raised to 4. Okay? So this will be our answer since we cannot cancel anything from it. All right? So how about last problem for this, for the division? Okay? So you have x squared minus 5x plus 6 all over, you have x squared plus 7x minus 8 all over, you have 9 minus x squared all over 64 minus x squared. Okay, so you have x squared minus 5x plus 6 all over x squared plus 7x minus 8. So get the reciprocal and proceed to multiplication. So you have 64 minus x squared all over 9 minus x squared. So factor. So you have, I think, for this one, you have negative 3 and negative 2. If you add negative 5, if you multiply, it's positive 6. So you have x minus 3 and x minus 2. And this we have, if you multiply negative 8, if you add positive 7, so you have 8 and negative 1. Okay, because the positive 7 is the sign. So if you add, that would be positive 7. So 8 and negative 1. So you have x plus 8, then x minus 1. And then you have 64 minus x squared. That would be 8 minus x and 8 plus x. Okay, by difference formula. And 9 minus x squared, we have seen this. This would be 3 minus x and then 3 plus x. Alright. So, yeah. We can, from here, from this point of view, we can have cancellation. But only for x plus 8. But if I get the negative, okay, if I get the negative sign again of the one here, so you have x minus 3, x minus 2, I have x plus 8, and then I have x minus 1. So if I get the negative sign, okay, if I get the negative sign here, that would be negative, you have x plus 8, okay, then you have 8 plus x, so if you get, that would be negative x minus 8, okay. But there's no need to get the negative sign of 8 minus x because we cannot just simply cancel, okay, so we're just going to go back, okay. So we have 8 minus x here, and this is what we need, okay, in 3 minus x. So I can factor out negative, and that becomes x, okay, minus 3, and then you have 3 plus x. So let's try. So if I have to cancel, you have x minus 3 cancelled, you have 8 plus x cancelled, and you are left with x minus 2 all over x minus 1 multiplied by 8 minus x all over negative of 3 plus x. Okay? So right now, you have x minus 2 all over x minus 1. If I get the negative here, so that the positive will become, or the negative x will become positive, this will become x minus 8, okay, negative x and positive 8 all over negative 3 plus x. So negative divided by negative will be cancelled. This will become positive. So you have x minus 2 all over x minus 1. Then you have x minus 8 all over 3 plus x, or x plus 3. So the answer would be x minus 2 times x minus 8 all over. You have x minus 1 and you have x plus 3. Okay, so that's the answer for this problem number 5. Okay? Okay. So how about if we try to go with addition and subtraction of fractions? So addition and subtractions. Not fraction, I mean of rational expressions. So for number 6, the first problem that we must have here is, let's say you have you have 5 all over 2x minus 3 all over 4x squared. Now the goal in addition and subtraction is to find the LCD. The LCD is the very least number or expression that the two denominators will meet. Okay? So you have 5 all over 2x minus 4 all over x minus 3 all over 4x squared. So the LCD is where they will meet. So you have 2 here, you have 4 here, they will meet at 4, and you have x here and x squared here. So the least common denominator would be 4x squared. So the LCD here would be 4x squared. And the goal is to make the denominator the same, so that we will be able to add or multiply or add or subtract the given rational expression. So if you first determine the LCD, okay, so you now have 5 all over 2x, okay. So what are we going to do is to make that, what do you call this? To make that denominator look like the LCD. So we're going to multiply this technically by 2x all over 2x. So multiplying it by 2x all over 2x, okay, is simply just multiplying it, okay, with respect to what? With respect to 1. Because 2x all over 2x is just simply 1. So we just multiply it, since if we multiply 2x then 2x, that will be 4x squared, of which that is our LCD. And then going on the right side, so you have 4x squared here, okay. So you're going to multiply it, since you have already 4x squared here, you're going to multiply it by 1 all over 1, which is technically by 1. Okay. So if you do this, this would become 5 times 2x all over 4x squared minus you have 3 times 1 all over 4x squared. Okay? So now you already have the same LCD. So you have now 10x minus 3 all over 4x squared. So I can just simply rewrite these two terms as a single term, okay, since they have the same denominators already, and I can minus it. Okay, so since we don't have any simplification further for our answer, this will be our answer. Okay, again, we have to find the LCD. Okay, so some of the techniques, okay, that are being done, sometimes they cross multiply, but they take note that if the LCD is already 4x squared, okay, you're going to have it 4x squared. Okay, so there are many ways, okay, but the number one thing here is to make the denominators the same. So you have 3a plus, okay, let's have 3a all over you have bc plus 2b all over you have ac. Okay, so again, the LCD here, we have both common c, okay. So the LCD should be, we have the same denominator. You have common C, so we'll have C here. And we have A also, and we have B. Because we need to complete, okay, the denominator. So you have 3A all over BC. To where shall I multiply this in order for the denominator to be ABC? So I have to multiply it by A all over A. Okay? Plus you have 2B all over AC. To whom shall I multiply it to be able to become ABC? So that would be B all over B. Because ABC. And then you have ABC. So if you do that, technically you're not doing anything wrong with the equation because you are just multiplying it by 1. A all over A is 1, B all over B is 1. And any number multiplied by 1 or any expression multiplied by 1 is still simply the expression or the number. So you have 3A times A all over, you have ABC, plus you have 2B times B all over ABC. So I can just simply write this as 3A times A plus 2B times B all over ABC. Because they already have the same denominator. So if I perform that, that would be 3A times A, that's 3A squared, plus 2B squared, all over ABC. Okay? And I think that will be our answer for this. Okay, for let number 8, so you have 3t minus 1 all over 10. And then you have 5 minus 2t all over 15. Okay? So again, what is their LCD? Okay. Their LCD is what multiple will they meet the soonest. So you have, if you know 10, 20, 30, that is 30. 15 times 2, it's 30. So their LCD must be 30. So now what I'm going to do is to make this, how I'm going to multiply it just so to make the denominator equal to 30. So I'm going to have 10 times, of course, 3. So 3 all over 3. Plus you have 5 minus 2t, 15. Of course, where do I multiply this to make this 30? Of course, in 2. So that should be 2 all over 2. So that's why we don't have to have any violation of the expression. So you have 3t minus 1 times 3 all over 30. Plus now you have 5 minus 2t times 2 all over, you have 30. So you have to multiply this. You have to distribute. Okay, so if you distribute, this would be 3 times 3t. So that would be 9t minus 3. Plus, okay, this is 30 plus, they have the same denominators. So plus 2 times 5, that is 10 minus 40 all over 30. So I can just simply write them as 90 minus 3 plus 10 minus 40 all over 30. Okay? So I just simply rewrite them as one rational expressions since they have already the same denominator. So simplifying, you have 90 minus 40, combining like terms, that would be 5t. And then negative 3 plus 10, that would be positive 7 all over 30. So can we simplify it further? I think we cannot simplify it further. So that's why that will be our final answer. Alright, so that is for number 8. So for number 9, I just simply we have 3 all over x minus 2 all over x plus 1. And then you have plus 2 all over x squared. Okay. So again, the LCD here, since we have x and x squared, so we'll be picking x squared because that is where they will meet. If you multiply x by x, it will be x squared. They will meet at x squared. But at the same time, we also have to have x plus 1. Okay? So we're going to force to make all of this to x squared x plus 1. So we have 3 all over x. Where do we multiply both the numerator and the denominator to make this x squared x plus 1. So simply that is x times x plus 1 because x times x is x squared, quantity x plus 1. So I have to multiply it by x also and x plus 1. And then you have minus, you have 2 all over x plus 1 here. Okay, so I have to multiply it by, I already have the x plus 1, so I only have to multiply it by x squared. Okay? X squared all over x squared. Don't forget that. And then plus 2 all over x squared. Where do I need to multiply this so that this would be x plus 1? X squared x plus 1. So only for x plus 1. So you have x plus 1. And now you can solve it. Okay? So now you have 3 times x plus 1 all over you have x squared x plus 1 minus you have 2x squared. 2 times x squared is 2x squared. Then you have x squared x plus 1 plus you have 2 times x plus 1 all over x squared x plus 1. So they all have the same denominator, so therefore I can just simply rewrite this as 3 times x plus 1 minus 2x squared plus 2 times x plus 1 all over you have x squared and then x plus 1. Alright? So that's how we do it. So just simplify. You now have 3x. No? So you have x squared plus x. Then you have minus 2x squared. You distribute this. So you have 2x plus 2. All over you have x squared and then x plus 1. So distribute again this. So you have 3x squared plus 3x minus 2x squared plus 2x plus 2. So combining like terms and simplifying. If we can simplify some. So you have 3x squared minus 2x squared. That is simply x squared. You have 3x and then 2x. 3x plus 2x, that is 5x. Then you are left with 2. So you have x squared and then you have x plus 1 in here. Alright? So we cannot factor out the numerator. Okay, we're gonna just cancel the x squared here because, you know, the x squared here in the numerator has plus. Okay, it's not multiplication. So the answer would still be this one. Okay, we can rewrite it as our answer for this problem. Okay, so for number 10, let us try. So for number 10, you have 5 minus, most probably this will be the last number or the second to the last. 5 minus 5 all over x plus 3 plus 10 all over x squared minus 9. So find the LCD first. So of course the LCD here, if you're going to look at x squared minus 9, that is technically x plus 3 and then x minus 3. Okay, so you already have x plus 3 here. You only have to have what? X plus 3 and then of course the x minus 3. And of course, don't forget that this 5 has a denominator of 1. So technically, we just have 1 or simply the LCD would be x plus 3, x minus 3. So we have to force all of these terms, okay, to have a denominator of x plus 3 and x minus 3. So what will happen? So you have to multiply it by x plus 3, then x minus 3 on the numerator, and then x plus 3 and x minus 3 on the denominator. Minus, okay, let me just delete this. Okay, minus, you have 5 all over x plus 3. So again, our purpose is the denominator. So if you already have x plus 3, I'm going to only multiply it by x minus 3. And then plus, you have 10 x plus 3 and then x minus 3. So no need to do here. Just multiply it by, of course, 1. Okay, 1 all over 1. So that's it. Okay, if we do this, that would be 5 times x plus 3, x minus 3, all over x plus 3, x minus 3. Minus, you have 5 times x minus 3, all over x plus 3, x minus 3 plus 10 all over x plus 3, then x minus 3. Okay? So we can rewrite it as 5 times x plus 3, x minus 3, minus 5 times x minus 3 plus 10 all over, you have x plus 3, and then you have x minus 3. Okay. So x plus 3 minus times x minus 3, that is simply 5 times x squared minus 9. Okay. That's x squared minus 9. Now take note, we have minus here of 5. So we have to distribute negative 5 along with its sign. So negative 5 times x would be negative 5x. Negative 5 times negative 3 would be positive 15 plus 10 all over x plus 3, then x minus 3. Now distribute. So you have 5x squared minus 45 minus 5x plus 15 plus 10 all over x plus 3, and then you have x minus 3. Okay, so 5x squared, can we simplify? Nothing. For negative 45, so you have negative 45 in here, and then you have positive 15 and plus 10. So 15 plus 10 is 25. So 25 minus 45 is negative. 25 minus 45 is negative 20. Okay? Then you have 5x or minus 5x here. Then you have x plus 3. Then you have x minus 3. Okay, I can still factor out, okay, 5x squared by simply getting the 5. Factoring out 5. So I have 5, I have x squared minus 4 minus x. X plus 3 all over x minus 3. Or, if I rewrite this, you have x squared minus x minus 4. Okay, all over, we have x plus 3, and then we have x minus 3. All right. So I think that is our answer. So the numerator, if you try to factor it out, it will not cancel any of the denominator. So there's no need for factoring the numerator. Okay, so for the last problem, okay, here's a set work for you. You can try. Okay, involve yourself, practice yourself. You have 3 all over y minus 2 minus 3 minus 2 all over y plus 2 minus y all over y squared minus 4. So this will be your set work, or this will be your take-home problem. I'll be pinning down on the comment section below the right answer. So for now, you can work on it. Okay, and I'm going to again continue complex fraction on the next part of this intervention for calculus. So I hope you learned something from this video. If you find this video helpful, please don't forget to subscribe to my channel for more mathematics tutorial for the intervention for calculus drafting course for engineering, and as well as for those who would like to review college algebra. So thank you so much, guys, and God bless. See you again on the next video. Bye.